turning the tide a new era in immune therapy. Vaccines have long protected us from infectious diseases. Traditional vaccines introduce a weakened pathogen to trigger an immune response. But what if we could harness the immune system to tame its own attacks? This is the concept behind reverse vaccines. Reverse vaccines train the immune system to tolerate, not attack. They hold promise for autoimmune diseases, allergies, and more. The goal is to restore balance within the immune system. Reverse vaccines could revolutionize medicine, ushering in a new era. Decoding reverse vaccines, a mechanism of tolerance. Reverse vaccines operate on immune tolerance, teaching the immune system to distinguish between harmless substances and dangerous invaders. Our bodies face foreign particles constantly. The immune system tolerates most, preventing harmful responses. Reverse vaccines induce tolerance to specific antigens. They deliver antigens to promote tolerance. Often these antigens are modified to dampen the immune response. The goal is to re-educate the immune system. Regulatory T cells, the peacekeepers of the immune system. Central to the mechanism of reverse vaccines is the role of regulatory T cells, often referred to as TREGs. These specialized immune cells act as the peacekeepers of the immune system, suppressing excessive immune responses and maintaining self-tolerance. TREGs are essential for preventing autoimmune diseases by keeping autoreactive immune cells in check. Reverse vaccines are designed to specifically activate and expand TREGs that target the disease-causing antigens. By boosting the number and activity of these regulatory cells, reverse vaccines tip the balance in favor of immune tolerance, effectively suppressing the unwanted immune attack. This targeted approach, focusing on specific TREGs, offers a more precise and potentially safer way to modulate the immune response compared to traditional immunosuppressants, which can have widespread effects on the immune system. Antigen delivery, the key to precision. The success of reverse vaccines hinges on the effective delivery of antigens to the immune system in a way that promotes tolerance rather than immunity. This requires sophisticated antigen delivery systems that can target the right immune cells and deliver the antigens in a safe and controlled manner. Various strategies are being explored, including nanoparticles, modified peptides, and even genetically engineered cells. These delivery systems can be tailored to target specific cells or tissues, ensuring that the antigens are presented in the most effective way to induce tolerance. The choice of delivery system depends on the specific antigen and the targeted disease. Researchers are continuously refining these systems to optimize antigen delivery, enhance tolerance induction, and minimize potential side effects. Section 5. Autoimmune diseases, a new frontier of hope. Autoimmune diseases, a group of chronic conditions where the immune system mistakenly attacks the body's own tissues, affect millions of people worldwide. These diseases, ranging from rheumatoid arthritis to type 1 diabetes, can cause significant pain, disability, and even death. Reverse vaccines offer a beacon of hope for these patients by potentially resetting the immune system and halting the autoimmune attack. By inducing tolerance to the specific antigens targeted by the immune system in these diseases, reverse vaccines could potentially prevent further damage and even reverse existing damage. For instance, in type 1 diabetes, the immune system destroys insulin-producing beta cells in the pancreas. Reverse vaccines designed to induce tolerance to pancreatic beta cell antigens could potentially protect these cells from immune attack, preventing or delaying the onset of the disease. Section 6. Taming allergies, a breath of fresh air. Allergies, another type of immune overreaction, affect a significant portion of the population, causing a range of symptoms from mild discomfort to life-threatening anaphylaxis. These reactions occur when the immune system overreacts to harmless substances like pollen, dust mites, or certain foods. Reverse vaccines offer a potential cure for allergies by desensitizing the immune system to these allergens. By gradually exposing the immune system to increasing doses of the allergen in a controlled manner, reverse vaccines can retrain the immune system to tolerate these substances, preventing allergic reactions. This approach, known as allergen immunotherapy, has already shown promise in treating certain allergies, and reverse vaccines represent a significant advancement in this field. By specifically targeting the immune cells responsible for allergic reactions, reverse vaccines offer a more precise and potentially more effective way to achieve long-term allergy relief. Section 7. Transplantation, bridging the gap between hope and reality. Organ transplantation offers a lifeline for patients with end-stage organ failure. However, transplant rejection, where the recipient's immune system attacks the transplanted organ, remains a major hurdle. Current immunosuppressive drugs, while effective in preventing rejection, come with significant side effects and risks. Reverse vaccines hold the potential to revolutionize transplantation by inducing tolerance to the donor organ, eliminating the need for lifelong immunosuppression. By training the recipient's immune system to recognize the transplanted organ as self, reverse vaccines could pave the way for safer and more successful transplantation outcomes. This approach could dramatically improve the lives of transplant recipients, freeing them from the burden of immunosuppressive drugs and their associated risks, and allowing them to live healthier, more fulfilling lives. Section 8. Research Breakthroughs. Illuminating the Path Forward. Research in reverse vaccines is rapidly progressing, with promising results emerging from preclinical studies and clinical trials. Scientists are exploring various approaches to optimize antigen delivery, enhance tolerance induction, and identify the most effective targets for different diseases. For instance, in multiple sclerosis, an autoimmune disease that affects the central nervous system, researchers are investigating reverse vaccines that target myelin, the protective sheath that surrounds nerve fibers. By inducing tolerance to myelin antigens, these vaccines aim to halt the autoimmune attack and potentially promote nerve regeneration. In type 1 diabetes, clinical trials are underway to evaluate the safety and efficacy of reverse vaccines designed to protect insulin-producing beta cells from immune destruction. These trials are crucial for determining the long-term benefits and potential risks of this novel therapeutic approach. Section 9. Benefits of reverse vaccines, a paradigm shift in medicine. Reverse vaccines represent a paradigm shift in medicine, offering a completely new way to treat a wide range of diseases by harnessing the body's own immune system. Compared to traditional treatments, reverse vaccines offer several potential advantages. Targeted therapy. Unlike general immunosuppressants, reverse vaccines specifically target the immune cells and pathways responsible for the disease, minimizing off-target effects and reducing the risk of side effects. Long-term efficacy. By inducing immune tolerance, reverse vaccines have the potential to provide long-lasting or even permanent relief from disease, reducing or eliminating the need for continuous medication. Wide range of applications. Reverse vaccines hold promise for treating a wide array of conditions, including autoimmune diseases, allergies, transplant rejection, and even certain types of cancer. These advantages make reverse vaccines a highly attractive therapeutic approach, offering hope for millions of patients worldwide who could benefit from a more targeted and potentially curative treatment option. Section 10. Challenges and Considerations, Navigating Uncharted Territory. While the potential of reverse vaccines is undeniable, several challenges and considerations need to be addressed as this field continues to evolve. Complex immune responses. The immune system is incredibly complex, and inducing tolerance is a delicate balancing act. Predicting how an individual's immune system will respond to a reverse vaccine can be challenging. Safety concerns. As with any new therapeutic approach, ensuring the safety of reverse vaccines is paramount. Thorough preclinical and clinical testing is essential to identify and mitigate potential risks. Individual variability. Immune responses can vary significantly from person to person, meaning that what works for one individual may not work for another. Personalized approaches to reverse vaccination may be necessary to optimize treatment outcomes. Overcoming these challenges will require continued research and innovation, but the potential rewards are immense. As our understanding of the immune system deepens and our ability to manipulate it improves, reverse vaccines hold the key to unlocking a new era of personalized and potentially curative medicine. Section 11. The Future of Reverse Vaccines, a Legacy of Innovation. The future of reverse vaccines is bright, fueled by ongoing research, technological advancements, and the unwavering dedication of scientists and clinicians worldwide. As we delve deeper into the intricacies of the immune system, our ability to harness its power for therapeutic purposes will only continue to grow. Reverse vaccines represent a bold and innovative approach to treating some of the most challenging diseases facing humanity. By shifting the paradigm from attack to tolerance, we have the potential to transform the lives of millions and usher in a new era of medicine where the immune system becomes a powerful ally in the fight against disease. The journey ahead is filled with both challenges and opportunities. Continued research, collaboration, and investment are crucial to realizing the full potential of reverse vaccines and securing their legacy as a transformative force in medicine for generations to come.